So in this video, I'm going to be showing you how to take a sprite sheet like this one and to turn it into separated animations for a player or any other object you might need to animate. So in our resources, you can see that I've already imported the PNG for the sprite sheet. Before we go ahead and create our character, I'm actually going to create a folder to move our art assets like the sprite sheet into. So if we right click on our resources root, and then choose new folder, we can create a folder called art for that. And I'm gonna drag my purple shirt sprite sheet into there. Okay, so now our art is stored in there. You might want to create another directory and call it characters and just kind of have things a little bit more organized, however you want it to be. But now let's create a folder for our character scripts and our character screens. So I'm going to right click on resources once again, do new folder. Let's type in characters. And now we can go ahead and create a new scene. So I'm going to go to the top left where it says scene and choose new scene. So let's create this as not a 2D scene actually, but a kinematic body 2D. So the reason we do that is that we want to be able to move the scene or character around the screen. And by giving it a kinematic body, it'll be able to collide with other objects that have their own collision shapes. So let's go ahead and use other node, and I'm going to type in kinematic body. So we want kinematic body 2D because we're making a 2D game here. So let's go ahead and hit create. So now, even if we go to the 0, 0 position here, we won't see anything in this scene. So the kinematic body doesn't have a sprite by default, but we can add one to it by right-clicking on the kinematic body and adding a child node. We're going to add a sprite node. So just search for that and then click on sprite. And now we can take the sprite sheet and put that into the texture for this sprite node. So I'm going to drag it from the art folder and just put it right where it says texture. So now we're kind of where we were before, except this is its own separate scene, and the kinematic body 2D is going to give us a lot of extra functionality later. So we want the root of this to be called player, so it's clear what this actually is. So I'm going to double click on the name here and type in player. And now let's save this as a scene in our characters folder. So Command or Control S and then go into characters and save the scene as a .tscn file. Hit save. Okay, great. So now one obvious problem is that in displaying this sprite with that texture, we're actually displaying every possible frame of animation that this character is capable of. So we want to break that down to only show one frame at a time. So if you go into animation, you can set the number of horizontal frames and the number of vertical frames in your sprite sheet. So if you have a smaller sprite sheet, one way to figure that out is just to count the number of characters you have going across and the characters you go down, and then that will give you your rows and columns. And then you can put that in for H frames and V frames. So I'm going to put in 57 by 20, and then that's going to roughly give us the size of our character here. But I do want to point something out. It's that when you divide up your sprite sheet like this, it needs to be a perfect fitting slice of the character. So as I increase the frame from 0 here, you'll notice that some of the frames aren't actually quite perfectly synced up here. So while the character can roughly be sliced up 57 times, if I actually open this file in a program like Sprite, which I will do now, I'm going to show in File Explorer, and then I'm going to open this with Sprite. Then what you'll see at the bottom left here, 927 by 656 pixels, is that this actually doesn't fit into divisions of 16 pixels here. There's actually some trailing information in this sprite sheet. So what I'm going to do is go up to the sprite menu, go down to canvas size, and we're going to trim away that extra information. So you can see that in the top left, it's already perfectly against the character frame. So I don't want to take any from the top left here. I actually only want to take away from the bottom and take away from the right. So if I choose this position, then when I pull in, it's only going to be pulling from this side and this side, not the left and not the top. So now you can just kind of adjust this. I'm going to pull this into here. And down here at the bottom, I'm going to pull this up to here. So now our character should actually fit a 16 by 16 pixel grid. To prove that, I'm going to hit OK to confirm our changes. And then I'm going to go up to View, let's see, Grid settings, make sure this is 16 by 16, and then View, Show Grid So as I mentioned before, our character always fits two 16 by 16 pixel squares, but doesn't necessarily take up the full size of the top one. I think it's about 24 pixels each for these character frames. But as we move around, you can see that now these squares, no matter where we go, there will never be any trailing information that would mess up our horizontal and vertical frame count. So now we just need to figure out how many times 896 divides by 16. So if your sprite sheet's big enough where you can't just count that, just open up a calculator and then divide the width by the number of pixels per frame, and we get 56. So now I'm going to export this back to our Godot project. Okay, let's find that file and just click it, overwrite it. Yes. Okay, I guess we have to use the Save As menu. So let's go to Save As. Okay, select the file, hit OK. Yes. Okay, there we go. So now back in Godot, remember, we figured out that with the resizing, it's 56 horizontal frames. So 56 here. And now as we increase our frames, no matter which frame we're on here, it should actually fit perfectly. So that's what we want to see when we are breaking up our sprite sheet using this hframes vframes method. So now I can go ahead and save our scene, and let's go ahead and add an animation player to our kinematic body so that we can actually play some animations. So I'm going to right click on our kinematic body at the top here, go to Add Child Node, Animation Player, just type that, search for it, and add that to our kinematic body as a child. So now when we click on the animation player, we should see animation pop up here as a bottom window. Let's create an animation by clicking on this animation button here. So animation new, and we could just call it idle right, hit OK. So when we're idling right, in order to display the correct frame, we can either use the frame setting over here or the frame coordinates setting. So one way to add the track is to hit Add Track, Property Track, choose the sprite, and then choose the property we want to change. In this case, I'm going to use frame coordinates. I think that's a little more convenient than frame because with frame coordinates, you can count the number of rows or columns that you're going down. I think it's a little bit easier than going through frame and then basically needing to manage hundreds of frames. Rows and columns just seems easier. So we can add that here, and then that'll show up as a property down there. But you may also notice in the inspector there's this little keyframe button. So if you want to add a property to the animation window, you can just click on the keyframe button for that property, and then that will add it down here as well. I think this way is a little faster. So I'm going to click on the keyframe for frame coordinates. I'm going to hit create, and you can see that property pops up here, and we can see a little icon of our sprite frame will appear here. If we added more, we'd be able to kind of see a preview of our animation down here. So it's a nice way of visualizing everything. Now, because we're doing a pixel art game, you want to change this drop-down setting from continuous to discrete. So just make sure you do that whenever you're changing the frame coordinates property so that it looks correct. So next, let's create another animation. So I want to get this walking right cycle and add it in as a animation. So I'm going to click animation, do new animation, and let's do walk right. I'm going to hit enter, create it. We'll click on sprite. And if we kind of tab back to asset right here, we can see that this is in the third row. So the rows start from 0. So this is 0, 1, and then 2 down here. So let's go ahead and select that. And by the way, the reason it's 0, 1, 2 and not 0, 1, 2, 3, 4, 5, because when I set up the number of rows, I'm dividing the rows actually by 32 pixels each. So if you actually divided the 640 pixels by 32, you'd get 20. So that's why it's 20 and not 40 inside of Godot. So really, if I wanted to make this grid make more sense, I could change view, go to settings, grid settings, and then the height can be 32. So now these are the actual frames that we're using. So really it's row 0, row 1, row 2. So let's alt tab back to Godot. I'm going to change the Y value here for the row to 2, and we can see the first frame for our walk here. So I'm going to use this keyframe button, and I'm going to add it as a property that changes for our animation. And then, of course, I'm going to change from continuous to discrete here. And I'm also going to check the animation looping because this animation is going to keep replaying while our character walks over the screen. So the next thing we need to figure out is what the speed of our animation playing back is going to be. So how long should each frame be? If you have a new frame every 0.1 seconds, then that's 10 frames per second. If you have a new frame every 0.05 seconds, then that would be 20 frames a second. So if you want to easily change it to 0.05 for the snapping, so you can add a new frame here, then you could go down here to snap and type in 0.05. We'll actually start with 0.1 here, so 10 frames per second, but we can adjust that later, and we'll see what actually works for us. So I'm going to zoom in a little bit. We'll go to 0.1 here, note the snapping, so we end up at exactly the point we need it. We're going to put in 1 for the X frame coordinate, and then I'm going to add the key there. So let's see, did that work? Okay, we have frame 0, frame 1. Okay, and the next one we need is frame 2. So I'm going to add that. Now note that when you click to add a keyframe, the value here increments by 1. So I can actually just click keyframe, 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 and that will create the rest of our frames here. And now you can see that when we get to 6 that we've actually entered our next animation. So what I'm going to do is actually shrink the duration of this track to 0.6 seconds so that each of these frames have an equal amount of time to play. So let's take the duration over here next to the time icon and type in 0.6. And let's hit play on our animation. And there's our walk cycle. So if we think this is a little fast, you can always spread it out, maybe 0.015 seconds per frame of animation, but I'm thinking this actually looks pretty good. So now we have our walk animation and our idle right animation. Okay, now we need to create a animation tree so that depending on the import we get later on from our player script, we can decide if we're showing the idle animation or the walk animations. So let's right click on our player object, go to add child node, do animation tree. So node animation tree. Okay, add that in. You'll notice we get a warning because we have no animation player or animation root. So let's click on AnimationPlayer over in the inspector and let's assign the animation player. So the animation tree basically controls the animation player, but the animation player is where we set up the actual animations. The animation tree just kind of helps us pick out which one we want. So in our tree root, let's choose a animation node state machine. So here we're going to be able to set up different nodes that will play back different animations depending on which node it's at. And we can set up the rules for how one node transitions to another, or in other words, how one animation switches over to another one, or when a character is idling, how can it walk instead of idling. So let's add in the animations we have, or well, for right now, we'll create it as simple single animations, but later you should really use a blend space 2D so that if your character's walking right or up, it'll switch between idle right or idle up. But we only have idle right and walk right for right now, so we'll just keep it simple. I'm going to add an animation, idle right, and I'm going to left click and add an animation, walk right. So by default, we want to start with idle animation. So I'm going to select idle and then click on this auto start icon over here. So this will be our start for our animation state machine. And let's click over here to connect nodes together so that one animation can switch to another. So I'm going to left click on idle right, and go to idle right. Okay, so now with our animation tree, let's click on it and set it to be active currently. Okay, so right now it's playing walk right. I'm going to click on idle right over here, which should be our default starting animation. And as long as this is set as auto, it should be where our animation state machine enters at the start. So you can switch between them here manually, but really we're going to want to control that with code later on. So for right now, I'm going to right click on our player and we'll add a script, and this will be called player.gd. So let's go ahead and create that. So you can click on the script icon in order to edit the script for our player. And in our player, we're going to want to get reference to the state machine inside of this animation tree. So it's not the animation tree, but really it's this tree root that we're going to get access to. And when you have access to that, you can tell it to travel between the different animations you want to go to. So you can say travel, and then in quotations, walk right, and it will find the shortest path to get to this walk right animation. So up here at the top for our script, I'm going to type in onReady var AnimationTree, and I'm going to hit equals $AnimationTree. So this $sign is going to make the script look at our hierarchy for this scene and try to find the node that has this exact name, get reference to it, but only on ready, which means when the script first loads. So when we're in the editor, it hasn't actually assigned this to our variable yet, but this will be active when the game starts. So the next thing we want to do is to get access to the state machine. So this would be another onReady var, and we're going to do state machine equals AnimationTree.get, and in quotation marks, parameters. And then in quotation marks, we want parameters. And then in quotation marks, we want parameters slash playback. Okay, so the state machine is going to be this animation node state machine. And note that this way of doing things only works if you're going to use a state machine as your playback. The other options like a blend tree aren't going to have the .travel function. So let's start by creating a scene where we'll instantiate a copy of this player onto. So I'm going to click up here and add a new scene. It's going to be a 2D scene. I'm going to rename it test map, I guess. And then I'm going to save it in our project in the root. Actually, I'll create a folder here called maps. And then I'm going to save test map into there. Now, in our file system, let's drag a copy of this player scene into here. We'll put it like right there for now, actually. So this should actually appear in the frame. You can kind of see the default camera back there. Should go from 0, 0 to these bounds. And now that our player is here, let's save the test map as the default scene to load for our project. So project settings, go up to, I believe it's run at the top. Let's change the main scene to test map. So maps, test map, close, and let's hit play. So what's going to happen is basically nothing. Our character is just going to be there at the start of the scene. But if we use the .travel function, we'll be able to switch over to the walk right animation. So let's go ahead and open up the script, and we'll do it on ready. So when our player first loads into the scene, we'll travel to the idle right animation. So state machine .travel, and then we put the name of the node we're trying to reach. So that was idle right, I believe. And then we can hit save. So to verify that, let's go back to the player, click on the animation tree, and we can see walk right here. So that's actually what we want. We want walk right, not idle right. So let's go ahead and hit save. And now we can hit play at the top. And now we can see immediately after the game starts, it's in the walk right animation. But if we close that and we take a look at our player, you can see that by default, it's not using the walk right. It's actually an idle right. So this only switches over after the game starts. So that's one way that you can control your state machine, is just to manually tell it in your code whenever you want to switch over animations. Of course, there's also other ways to do it, such as setting up a advanced condition and turning on auto advance. But I think this is the easiest way to understand for right now.